Hello, ladies and gentlemen. Today we're going to talk about uncertainty in measurement and percent error. So, first, with any measurement, there is a degree of uncertainty. This is caused by using an incorrect instrument, using the instrument incorrectly, and finally, estimation. Here are some important definitions: measured or actual value, a quantitative value that is measured or found during an experiment. Accepted value, a quantity used by general agreement in scientific community. Error, the difference between experimental value and accepted value, or measured value and accepted value. And percent error, the percent that a measured value differs from the accepted value. Here's our formula for percent error. Percent error equals the absolute value of measured minus accepted divided by accepted times 100. We're going to do 3 different examples. 2 are on this page and 1 is on another page. Notice everything that I write. You will be expected to do the same on all of your homework and quizzes or tests. So students mass a 25.00 gram weight. Student A measured 24.81 grams. Student B measured 25.24 grams. In this example, the accepted value is what? If you said 25.00 grams, you're correct. Student A's actual value, or what they measured, their measured value, is 24.81 grams. Student B's measured value or actual value is 25.24 grams. All right. So first we write out our equation. Q equals Q. Sorry. Percent error equals the measured minus the accepted divided by the accepted times 100. So we have our measured for student 1 or student A minus our accepted value. Don't forget your units, divided by our accepted value again, the absolute value of that times 100. When you put that in your calculator, you should get a negative number. So we want the absolute value, so it's going to be a positive number. And when you multiply by 100, you're going to get 0.76%. So that's our absolute value for A. In B, we're going to do the same thing. So we have percent error equals the absolute value measured minus accepted divided by accepted times 100. So we have student B's actual measured value is 25.24 minus 25.00 divided by 25.00. The absolute value of that, and then multiply by 100. You should get, when you do this part, you should get 0.01. When you multiply by 100, you will get 1%. So, which student has the lowest percent error, or which student is more accurate? Student A. So if you would like, go ahead and pause the video, see if you can work out the second example and try to get the correct answer before I go through it. Now would be the time To do that, I'm going to go ahead and go through this second example. So our first step is to write the equation. Percent error, that's this weird D looking, equals measured minus accepted divided by accepted times 100. Then I'm going to go ahead and enter my appropriate values wherever they are. So the question says, working in the lab, a student found the density of a piece of pure sodium to be 0.92 grams per centimeter cubed. The accepted value for the density of sodium is 0.97 grams per centimeter cubed. What is the percent error? Filling in my equation, I have the measured, which is 0.92 grams per centimeter cubed, minus the accepted or value, 0.97 grams per centimeter cubed. Then I'm going to divide again by our accepted, 0.97 grams per centimeter cubed. And finally, multiply by 100. So when I do that, when you do this part, you should get negative 0.051546 392. So in our other problems, we didn't really have to worry about significant figures because they only had a certain number of digits. But in this one, we're going to have to. So you take the absolute value of that and then multiply it by 100, and we get 5.1546392%. Our problem, our numbers that were given in our problem have two significant figures. So we only want the first two significant figures. So our answer is 5.1%. All right, you guys have a worksheet to do. There are 6 questions on your worksheet. Okay, you guys have a worksheet to do. There are 6 questions on your worksheet. Make sure that in order to get credit for your calculations, you are doing all of these steps, showing the formula, showing your work with units, rounding your answer to the correct number of significant figures. These are 3 options for how you do your homework tonight. You may print out the worksheet and send me back a picture with your problems worked out. You may put your work on a separate sheet of paper and send me the picture and attach it to your document. Or you may use a tablet to write on the document using the Kami extension. Please make sure that no matter how you do your work, it is legible, and that when you take a picture, it is in a well-lit area. And please write your name on top of each page in ink. Thank you, ladies and gentlemen. Have a wonderful day. If you have any questions, please feel free to message me. Bye.